All right, so I've decided to include one more example for you guys to explain to you guys for Hess's law. I know that of all the problems that were assigned, there was only 3 on the first assignment and 5 now on this second assignment. And, they can take a bit of time. So after looking at all of them and reading, some of your requests, I did look at number 5, and I think 5 is the best one to explain, just because it is one that has a lot of different components that you need to focus on. For example, so let's just recap. What is the point of doing Hess's law? The equation that they give you is the equation that you want to achieve at the end after you add up all the 4 steps. Sometimes it's only 2 steps. It could be 3 steps. This one happens to have 4 steps. It could have more than that as well. But the point is that all of these separate steps have to happen in order for this final equation to be achieved, for this final reaction to be achieved. So you need to manipulate these equations, these steps, to get the overall equation, okay? So a couple things to look for. When do you have to multiply by a factor? When do you have to divide by a factor? When do you have to look at states of matter? For example, this one has AlCl3 solid. Well, in the steps, you have AlCl3 aqueous, AlCl3 aqueous, AlCl3 solid. So you need to manipulate it in such a way that your final answer is going to be AlCl3 solid. Also, notice that in the steps, there's H2. You have to make sure that the H2s cancel, because there's no H2 in the overall equation. The HCl's also need to cancel, and there's 2 different types of HCl. There's aqueous and gaseous. So you need to do what you need to do to get those to cancel out. So I'm going to go ahead and go through the steps so you guys can see the different ways that the equations can be manipulated. So again, overall, this is what I want. I want 2Al plus 3Cl2 to form 2AlCl3, okay? And very important that this needs to be solid, okay, in your final answer. All right, this one needs to be gas, and this one needs to be solid. Okay, so I look at the first one. What am I going to need to do to that first equation to get it to match the overall? So I look at it and I'm like, okay, well, I need 2 aluminums on the reactant side, right? So this first equation has 2 aluminums on the reactant side. So this already gives me one of the pieces that I need. And if I look at all the other 3, there's no other ones that include anything about aluminum, just aluminum solid. So I'm going to leave the first equation here just as it's been given to me. So leave the first equation alone. Okay, just like that. Just rewrite it just as it's given. Notice that I made sure that I put the aqueous and the aqueous here because those are going to matter. All right. And so I didn't do anything to the delta H value there. Okay. Second equation. What needs to happen to the second equation? Well, if I look, it's HCl, and there's no HCl here. But there was HCl in the first equation. So I'm going to need those 6 aqueous HCl's to cancel. Well, okay, so there's HCl aqueous on the product side, which is good, but I need 6 of them. So I'm going to take the second equation, I'm going to multiply the whole thing by 6. And when I say multiply the whole thing by 6, even the delta H value, right? So times 6, notice I've circled over here what I'm doing to each equation. 6 HCl gas makes 6 HCl aqueous. And again, I need that because I need those 2 to cancel right there. 1 on the reactant side, 1 on the product side, and then I multiply by the delta H by 6 as well. Okay, third equation, what do I do there? Okay, so for the third equation, I'm looking at it and I'm like, okay, well, in the previous one here, I multiplied this by 6, so I have 6 HCl. And what am I going to have to cancel? I'm going to have to cancel these gaseous HCl's, but I only have 2. So that's one way to look at it. Another way to look at it is the overall equation doesn't have any H's, and the first equation had 3 H2's, right? So I need to cancel those hydrogen gas molecules. So that needs to be multiplied by 3. So there's two ways of looking at this one. Actually there's three ways. So either you look at canceling the gas HCl by multiplying it by 3, because there's 6 of these, right, from the previous one, or that you're going to need to cancel these 3 H2s, so multiply that by 3, or that the overall equation has 3 chlorine gas molecules, and so you're going to need to multiply that by 3. So regardless, looking at that third equation, no matter which one you look at, you need to multiply that by 3. So that's what we do to the third equation. We multiply everything by 3 so that these 3 H2s are going to cancel with those 3 H2s, so that overall I have 3 chlorine gas molecules, because I have in my overall equation 3 chlorine gas molecules. And so that these 6 HCl gas molecules will cancel with these 6 HCl gas molecules. So you multiply the third equation by 3, which gives us, and then you have to multiply the delta H by 3 as well. Okay, and finally, the last one is AlCl3 solid to AlCl3 aqueous. Okay, well, check this out. We need, on the product side, 2 AlCl3 solids. Well, the solid here is on the reactant side, so I need to flip this equation. So flip it. And also, I need 2 of them, so I need to multiply by 2. Okay? That is also going to aid here, because look, remember we had 2 AlCl3 aqueous here? We need to cancel, so we need 2 of those to cancel. So for the last one, for the fourth one, look, we need to flip the equation. So I've flipped it, which means that the sign changes. So instead of negative 323, it's positive 323. And I have to multiply it by 2 because I need 2 AlCl3 solids. So multiply by 2, everything multiply by 2, even the delta H. Okay, that should give us everything that we need for everything to cancel out. So then what I did is I literally rewrote everything over again. So I rewrote all of the reactants, everything before the arrows, and I wrote them down. So 2 aluminums plus 6 HCl aqueous plus 6 HCl gas plus 3 H2s plus 3 Cl2s plus 2 aluminum chlorides aqueous. All of that is right here. 1, 2, 3, 4, 5, 6 reactants. 1, 2, 3, 4, 5, 6 reactants. And then on the product side, 1, 2, 3, 4, 5 products. 1, 2, 3, 4, 5 products. When you look at what's on the product side and what's on the reactant side, and you cancel things out, again, where's my arrow? Here's my arrow. So the 6 aqueous HCl's cancel, 6 aqueous HCl's. The 6 gaseous HCl's cancel, 6 gaseous HCl right there. The 3 moles of H2 cancel, 3 moles of H2. The 2 moles of aluminum chloride aqueous cancel, 2 moles of aluminum chloride aqueous. And what we have left over is only 2 aluminums plus 3 Cl2 gas, forming the 2 moles of aluminum chloride solid, which is our overall equation. Okay, so now to calculate the delta H, right? Now you're going to take all of these values, and this is everything that you did. You left that one alone, you multiplied that one by 6, you multiplied that one by 3, you flipped this one, so you changed the sign, and you multiplied it by 2. You take all of those values, add them up, and that gives you your final value of delta H for this reaction. Okay?